Okay, good afternoon everyone.
Good afternoon.
Good afternoon today is our in-house training. Okay, today I will learn about the basic part of car. So it's the engine and also performance, right? Okay. So actually engine got three steps actually. Okay, first is a flash. We call bosses lah. Okay, second is VTEC, and one is inline tap. Okay, so actually in our Proton product we use which step? Inline lah, right? So all Proton engine is inline tap. Okay, so so-called the bosses engine is Subaru lah, alright? Subaru use the bosses engine, and VTEC so-called the V6 engine, right? So why inline engine? We can see here why Proton use the inline engine is compact size, okay, simplicity and cross effectiveness. Okay, so improve fuel economy. Okay, so Proton all models use the taps engine, right? So next, so this is the operating principles for engine. We know we have intake, okay, compressor, contribution, and exhaust. Okay, four things. Okay, for engine operation. Right, you can see the engine here. And then first, of course, we have fuel and air, piston, compressor, and spark plug. Okay, and smoker remover. Right, this we call the bar. Okay, next. Okay, so we have listened on the engine when we talk with customer, or sometimes customer will ask us how many torque and horsepower. Actually, what is a torque and horsepower? The torque is the turning focus of the engine to perform work. So the power, okay, the power reduced and produced by an engine is called is horsepower. So different things. Torque actually is I think simple to say is pickup new customer. Okay, so the torque is horsepower, right? Okay, so I will show you one video. Okay. So it's the top, right? And so the
because for the first time ever, these Titans will now go head to head in a
McLaren vs Ferrari. No, Bugatti. See the video will show you what is the torque and the horsepower.
He saw his first camera.
Bugatti, see?
Today that cloud is working as really nice. If we do together though, he doesn't know the direction. On paper, that's got 100,000 horsepower.
I think Bugatti is V8 engine. V12 twin turbo. Three top. Bugatti. One, go. So I think Bugatti will win in the horsepower. Bugatti will win. Who will win? Bugatti 開啊 See, V12 後面飆下來啊，後面飆下來，係啊，哎呦，呢個反派。 Yeah. See? You see? Okay, so this video we can see Bugatti vs the McLaren. So McLaren engine I think is inside that, and the engine will power the perform on the top. Okay, so when we pick up Bugatti, the McLaren will go first, and Bugatti use the V12 engine, so the perform on the horsepower. So in the end, the winner is Bugatti, right? So this is the engine difference. Okay, so this one is a VAR Okay, so now in our problem products we have SOHC. We thought the single camshaft, and DOHC. Okay, we call twin cam. What is the difference is they are single overhead camshaft. Okay, camshaft is driven by the wheel or engine. Okay, so far our proton product is use the wheel Okay, for price model is use the wheel. I think S model also use the wheel, but no more timing chin. Okay, yeah. Okay, 1.8 is timing chin. Right. So 1.5 use the wheel one. Okay, and those camshaft. Okay, which model we use the door camshaft? Door camshaft. Proper model. Okay, actually is S series. I think S series all use the door cam. So the door over camshaft. Okay, is the latest bar system. Okay, for the power So we can look in the below here. Okay, those advantage and benefit actually more power, better fuel consumption, better efficiency, and high compression ratio. Okay. Okay. So next, so we see the video. This video.
SOHC and DOHC. These represent the valve configuration inside an engine head to control the action of the valves. Though these configurations are renowned for their superior performance, both have some significant differences. SOHC stands for Single Overhead Cam. This type of valve configuration utilizes only a single camshaft for operating both intake and exhaust valves. DOHC, or dual overhead cam, on the other hand, utilizes two independent camshafts for the operation of the intake and exhaust valves. Let's have a look at the SOHC configuration. An SOHC engine head is packed with intake and exhaust valves, rocker arms, rocker arm shafts, and a single camshaft. The camshaft is designed in such a manner that the cam loads will push the rocker arms at corresponding timings to open the valves. The return springs ensure that the valves lift back afterwards and keeps tension back on the loads. SOHC design typically allows a 2 or 3 valves per cylinder configuration, or usually 1 valve for intake and 1 for exhaust, or 2 valves for intake and 1 for exhaust. However, current industrial competencies allow production of 4 valves per cylinder configuration using SOHC. Due to the reduced count of parts, the design complexity and manufacturing cost is comparatively low for SOHC engines. Since the mass of the valve train is lesser in such a configuration, SOHC engines tend to produce more torque for its low to mid RPM and provide improved fuel efficiency. The DOHC was later introduced with improved volumetric efficiency for an internal combustion engine. In this configuration, the head is packed with intake and exhaust valves, cam followers, and 2 independent camshafts. DOHC uses 2 separate camshafts per bank of the cylinder head. This allows all the cam lobes to directly operate the valves rather than using rocker arms as in SOHC engines. Here also, the return spring ensures that the valves lift back and keeps the tension on the camshaft lobes. DOHC usually implements a 4-valve per cylinder configuration, 2 valves for intake and 2 for exhaust. This configuration has a better valve lift, resulting in improved airflow through the combustion chamber. With less airflow restriction, the DOHC is even capable of generating more horsepower out of smaller displacement. Though this configuration can provide better top-end power, the design complexity and increased components result in more weight and a higher cost of production. When it comes to choosing between SOHC and DOHC engines, both have its own pros and cons. Let's look at some points briefing the presentation.
So this for double camshaft function. Okay. So this fuel injection system. Okay. So we have a direct injection.